Okay, good day, dear students. We are now looking into topic 2 of semester 2, which is integration of a function. Okay, now let's look at the learning objective for the first lesson. By the end of the lesson, students should be able to relate integration and differentiation, define the basic rules of integration, find the integral of exponential function, 1 over a function, and also exponential function where the base is a constant. Okay, now first we start with the relation between integration and differentiation. So integration is a reverse process of differentiation. Let's say we integrate a function and then we differentiate, we will get back the same function. For example, if differentiation of capital Fx is small fx, then the integration of the small fx is the capital Fx. Okay, for example, let's see how to show that 2x to the power of 5 plus 4 is an antiderivative of 10x to the power of 4. Okay, so we are going to show that 2x to the power of 5 plus 4 is the antiderivative of 10x to the power of 4. So what we are going to do first, we are going to differentiate 2x to the power of 5 plus 4, which give us 10x to the power of 4. So this is the answer for the differentiation. Now we are going to integrate the function that we get, which is 10x4, and we will be getting 10x5 to the power of 5. Do not forget to plus c, or 10 divided by 5 is 2x5, 2x to the power of 5 plus c. So note that we are getting the same answer as the antiderivative here. So we are getting the same answer except that we do not know the constant. Therefore, when you differentiate 2x to the power of 5 plus 4, we get 10x to the power of 4. And when we integrate 10x to the power of 4, we actually get back to x to the power of 5. We can say that 2x5 plus 4 is an antiderivative of 10x to the power of 4. Okay, next we are going to look at the basic rules of differentiation. So what happens when basic rules of integration. What happens when we integrate a constant? Okay, for example, k, we will be getting kx plus c. Or if we integrate 2, we will be getting 2x plus c. And also what happens when we integrate x with the power of n? We need to add up the power and divide by the new power. For example, x power 2, add up the power will become x power 3 and divide by the new power. Okay, both these rules can be summarized as below. And when we have multiplication with a constant and we want to integrate, we can always bring out the constant. We don't have to integrate when it's involved multiplication. Okay, and when we have addition or subtraction, we can separate them to integrate. Okay, and also the power rule. Okay, same as the previous, you need to add the power and divide by the new power, and also divide by differentiation of the given function. Okay, now we need to be very careful about integration that involve multiplication. We are not allowed to separate them. So we are not allowed to separate them. Okay. Same goes for multiplication. We are not allowed to bring out the function. And also for division, we are not allowed to separate the integration of division. Okay, now let's look at example 1. Okay, what happens when we integrate negative 3x to the power of negative 2? So we are going to use the power rule that we learned earlier. So what we are going to do here with the power is we are going to add 1 to the power, and we are going to divide with the new power, which is negative 2 plus 1, and we are not forgetting the plus c. Okay, so when we simplify this, we will get negative 3x negative 1 divided by negative 1 plus c. Negative divided by negative, we will be getting a positive 3. We can always write x to the power of negative 1 as over x plus c. 3 divided by x plus c. Okay, I hope you can follow this. Now we are going to go to the next example. Integrate 1 over 9 x to the power of 3 dx. So what we are going to do here, as we learned in one of the rule, we can factorize. We can bring out the constant, and we only need to integrate 1 over x cubed dx. Of course, we can't integrate 1 over x cubed, so we are writing 1 over x cubed as x to the power of negative 3. And we are going to add 1 to the power negative 3 plus 1, we are getting negative 2, divide by the new power, and do not forget to plus c. To simplify this answer, we will be getting negative 1 over 18 x to the power of 2 plus c. Okay. So for the next example C, integrate 3x squared minus 6x plus 4 dx. So since this is involving addition and subtraction, we can always integrate all this separately. So we can integrate 3x squared as 3x cubed over 3 and negative 6x at 6x squared over 2 and plus 4x. When we integrate constant, we get x plus c. So simplifying this will give us x cubed minus 3x squared plus 4x plus c. Okay, so next, example D, integrate 1 over 3x minus 10 to the power of 6. So we can't integrate if it's at the denominator. So we are going to bring it to the numerator. So power 6 will become power negative 6, and we're going to add 1 to the power. So negative 6 plus 1 is negative 5, divided by the new power, which is 5, and also we are going to divide with differentiation of the function. So differentiate 3x minus 10, we will be getting 3. So we are going to divide by this 3, and then we will be having a plus c behind here. So the final answer, 3x minus 10 to the power of negative 5 divided by negative 15 plus c. That will be the answer for D. And next we are going to look at integral of a special case, which is 1 over x power 1. So this is a special case because the power of x is 1. So we can't integrate 1 over x as normal. Okay, we can't bring this to the numerator, and we can't integrate this. We can't add 1 to the power. So this is wrong. If you are adding 1, then you will be getting x power 0, which is not going to be the result for this. So this is a special case where we will not integrate this as normal. The integration of 1 over x is ln x plus c. Same goes for 1 over ax plus b will be ln ax plus b divided by a. So this only occurs for x, 1 over x, where the power is 1. Okay, only occurs when the power is 1. Okay, let's look at example 2. How to integrate 5 over 3x. So we are not going to integrate, we are not going to bring the x to the numerator. Okay, that's a very wrong way of doing this. This is a special case where the x is power 1. So the answer will be ln x plus c. So next we will be getting 2 ln 5x plus 3. Do not forget to divide by 5. So from where we get 5? Differentiation of 5x plus 3 is 5. And of course, don't forget to plus with c. So you can write your answer as 2 over 5 ln 5x plus 3 plus c. Okay. Next, we are going to look at the integral of exponential function. So when we have x at the power, we call this exponential function. So what happens when we differentiate a to the power of x? Step 1, we are going to copy back the function. Step 2, divide by ln of the base. And what if we have bx plus c? Step 1, we will copy back the question, divide by ln of the base, and also divide by differentiation of the power, which is bx plus c. Let's try the first question here, 5 to the power of 4x. What happens when we integrate 5 to the power of 4x? First, we will copy back the question, divide by ln of the base, which is 5, and also divide by differentiate 4x. So differentiate 4x, we will be getting 4. Okay. So the final answer for this will be 5 to the power of 4x divided by 4 ln 5 plus c. Okay, same here. First step, we are going to copy back the question. Second step, we are going to divide by ln of the base and also divide by differentiation of the power. Differentiate to x minus 3, we will be getting 2. So 3 to the power of 2x minus 3 divided by 2 ln 3 plus c. Okay. So next is also exponential function. Okay. So what happens when we integrate exponent 3x plus 4? Same as the previous. We are going to copy back the question, divide by ln of the base and also differentiation of the power. So differentiate 3x 4 will be giving us 3. Okay, so we know ln exponent is 1. So the final answer 3 exponent to the power of 3x plus 4 divided by 3 plus c. So we don't have to write the ln of the base in this case. Okay, now let's look at example D. How to differentiate exponent 2x minus 3 divided by exponent x. So since this is involving subtraction, we can always integrate this separately. So we can take exponent to x divided by exponent x minus with 3 divided by exponent x, so that we are able to simplify. So what happens when we simplify exponent 2x divided by exponent x? We will be getting integral of exponent x minus integral of 3 exponent negative x dx. So we have not integrate this. Okay, next is the step where we are going to integrate. Copy back the question. Divide by ln of the base. Ln e is 1. Differentiation of the power is also 1. Same goes for the second part here. Copy back the question. Divide by differentiation of the power is negative 1 plus c. So final answer, exponent x plus 3 exponent negative x plus c. For example, 4. Okay, now for we are going to enter the second subtopic, which is 2.2, integration of trigonometry function. I will be seeing you all, I will be covering this in our next video. Thank you.